Another draft physics video presentation. Bonus material, bonus video. I have a little extra time, so I'll throw it in here. So AB Science, he provided as one of his proofs of something, his evidence, a link to the wrong diffraction, right? So he linked me to Fresnel diffraction, which has to do with stuff that's really, really, really close. An experiment done in a very tiny space versus experiments done over very long distances, which is Fraunhofer diffraction. So I just point out he couldn't even link to the right kind of diffraction. I mean, completely wrong one. Okay. And the right page is so bad that, it deserves some inspection, and I'll just point out how this is their physics. It's so bad. It's laughably bad. It's mockably bad. It's a flat earth page. Okay, it doesn't even come close to making any sense at all. It's not an answer to the question. It's just part of the propaganda. These are people who, they defend this crap. They're like preachers who have never read the Bible. So they preach and advocate that this is the truth, and they never read this crap. They don't even read their own theory. They don't even understand their own theory. It's like, when they attributed the discovery of gravitational waves to the realization of Einstein's vision, when Einstein didn't envision it at all. If Einstein was alive at the time, he would have said, please quit sticking my name on your crap. Okay, I never said you could turn frickin' matter into bent space. That wasn't part of my theory. It's like when these idiot trolls sit there and try to claim, I'm advocating some God frame because I say exactly what Einstein said, and that is the speed of light is the same everywhere. There's no such thing as a speed of light frame. Okay, there's no such thing. It always does exactly the same thing. It covers a certain amount of distance in a certain amount of time. And all you can do is screw up your perception of it. So yes, if you want to watch something that takes place over 1 billion years, you might be able to see yourself catch up to a flashlight beam, while you're moving the speed of light or something. But it'll take millions of years and blah, 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 blah. It has nothing to do with the truth. The truth is the photons always do the same thing. And that's what Einstein said. And so you're all such stinking liars. You put words in Einstein's mouth, and then you sit there and try to put words in my mouth. You can't sit there and do anything honest. You're just such despicable garbage. But anyway, all right, so I'll just read pieces of this as we'll just go through it. But I mean, it has just stupid statements in it. I mean, they're just stupid. All right, so Fraunhofer diffraction equation is used to model. There's no real hard, equation here. It's the same dopey stuff. You take a distance between two sources, and the thing that makes it a little, well, I'll get to that part. Anyway, equation is used to model diffraction. So this really isn't about diffraction. It's about interference, and diffraction as a concept is nice, but frankly, they don't explain it. They don't explain how you take something that's supposed to be flat, plain waves, and then you turn them into nice little round waves. They have no explanation, because in water and sound, we know how it happens. We know that the disturbance is molecular, and that the molecules stick to the surfaces. So if you put sound or you put water over a surface, it sticks to it. It slows down. It has friction. And that friction is what rounds the waves. I mean, that's just, that stuff, I'm saying third graders could grasp these concepts. Okay, so there's no mechanism for any of this. They just say words like Huygens and think I've explained it. They haven't explained anything. All right, anyway, Huygens would not agree with their interpretation of Huygens. That's how bad all of this is. They're putting concepts and putting somebody's name on it, and it's so rude. They're dead. They can't protect their reputation, and you're putting these stupid concepts in their mouth. You're saying they were advocates for this nonsense, when that's not what they suggested. Anyway, diffraction of waves. When the diffraction pattern, so again, they keep using the word diffraction, and again, at least Professor Lewin sort of has the integrity. He only does it because he's such a Huygens fan. But anyway, to point out, it's always interference. These patterns are not created by diffraction. Diffraction doesn't make an interference pattern. So it's kind of silly to talk about interference and call it diffraction, because they're not the same thing. I mean, I shouldn't have to explain this part to somebody, so this is sort of a waste of time if I'm going to explain the simple facts. But diffraction just has to do with spreading. Okay, so diffraction is just turning something into this, right? Rainbowing it. Creating a bulge or whatever you want to say. That's diffraction. It goes the same everywhere, blah, 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 blah. That's diffraction. Interference is having an complete destruction and construction, having something that is and isn't, is and isn't, is and isn't. It's a very different concept. The two things aren't the same thing. And all these patterns we're talking about are interference patterns. They are not diffraction patterns. So, I mean, they can't even get the simplest vocabulary right. All right. I mean, they can't do it in any kind of way that would give anybody an honest impression about what's going on. I mean, to call the pattern in the single slit with light diffraction is overtly dishonest. Okay. And also when viewed at a focal plane of the imaging lens. So again, they'll say later, on the focal plane or on the imaging plane. And again, I shouldn't have to explain this to anyone who's got any kind of understanding. Once you think about it and what the idea is of any kind of point source creating light, if you image anything, again, I've pointed this out. You all know this from movie screens nowadays, right? When people bought these big TV screens, well, they started to bend the screens, right? So if you got like one of those 120-inch things or whatever the hell they are, they're bent. Okay, you're buying a curved screen. Why are you buying a curved screen? Well, you're doing it because that's the only way to see the image the way it's supposed to be, without it being distorted. So we know if you put it on a flat plane, that something that's really supposed to be this size will end up being this size. And the further away, the more it stretches. So the further you go this way, the more distortion there is in the image if you view it on a flat screen. It's clearly not the ideal. It's clearly not the mechanical truth. If you want to see the truth, you view it on a curved screen. And if you do that with the slit patterns, all of them, the fact is that there's always just one pattern. Okay, and all you're saying is, yes, the same pattern here, it's the same pattern here, it's the same pattern at all of these locations. It's the same size of notches, okay, the same percentage of this line has notches on it. So if there's 5 notches, there's 5 notches on each one of these. Each one will always have the same number. It's the same pattern. There's no infinite pattern. No pattern goes this way infinitely. There's no fringe pattern that just keeps going this way. And that's the impression that's given. That's the impression I had because of their deceptive writing and because of their deceptive propaganda. You get this impression that this is the rational way to view something when it's completely irrational. You can't view a point source on a flat screen. If we viewed gravity on a flat screen, it wouldn't look right. It wouldn't work right. The math wouldn't fit. Nothing would make any sense. You have to consider this equal distances. You cannot do it by having completely unequal distances. So, I mean, their own math doesn't work. This math won't do what it's even saying. Well, when you view it on a flat screen, and this is with the number, no, those numbers won't work because there'll be huge distortion. If Daffy Duck is over here, okay, and there's his brother's over here, this guy's going to look so much fatter than this guy, even though they're the same size. The math won't work. It's that bad. So they suggest viewing it a certain way that you shouldn't even view it. You shouldn't conceptualize it that way. You shouldn't understand it that way. If they did it with point charges, if they did this with charge or magnetism or gravity, if they did the same stupid thing, okay, in terms of calculating intensity, they'd get wrong answers all over the place. I mean, it's just so fundamentally wrong to teach this subject so badly. All right. in contrast to the diffraction pattern created near the object. So let's just understand, right? The page he linked me to is for the near field. He didn't even give me the right page. He couldn't even do that much. All right. So it was named after Fraunhofer, although he was not actually involved in the development of the theory. So this is the funny part, right? They named the diffraction after somebody who they concede had nothing to do with it. Oh, that's just too brilliant. Oh, I mean, that's, you can't even get the guy's name right who invented it. Isn't that just so pitiful? All right. The article explains where the Fraunhofer equation can be applied and shows the Fraunhofer diffraction pattern in various apertures. So they admit it's the wrong guy's name on it, and they just keep saying it, and it's a really terrible name. I mean, it's some foreign thing that you have to pronounce some foreign way. Anyway, detailed mathematical treatment of Fraunhofer is given in the Fraunhofer diffraction equation. So again, it's the same bullshit. It's the same converted into two waves, and it's just nonsense. When a beam of light is partially blocked by an obstacle, some of the light is scattered around the object. So isn't that the funny word they just used? Yeah, yes, that's exactly what it's doing. It's scattered at the surfaces. So aren't they just admitting it right here? Aren't they just telling you right here we're full of garbage? Because what they basically just said is, okay, I have an object and the light's going to get scattered at the surfaces. And so when you do your double slit or your single slit or some other thing, right, they're basically saying I can put any appendage, like I say, a quarter, and the edges of the quarter are a surface, and the light is going to scatter. That means it's going to go this way, and it's going to go this way, and it's going to go this way, and it's going to go this way. Some of it, at any one moment, it can be going this way. Just like with a charge or anything else, at any one moment it could be going this way. At any one moment it could be going this way. And if you take an average, it just averages out to be a bulge in all these directions, blah, blah, blah. And they just called it scatter. So they're not unaware of the concept. And it has every appearance that that's exactly what's happening. The light that goes near the surface ends up being affected. The light that doesn't go near the surface doesn't get affected. It's that simple. Light and dark bands are often seen at the edges of the shadow. So there's light, goes this way, and some of the light goes that way. Yeah. This effect is known as diffraction. So again, they use the word diffraction, which diffraction just has to do with bulging something, taking something and spreading it. These effects can be modeled using Huygens-Fresnel principle. No, they can't be modeled, so that's a lie. They will not model this in any way whatsoever. They'll never be able to draw you a picture because it's absolute nonsense. And it actually has nothing to do with Huygens. Huygens postulated that every point on a primary wavefront acts as a source of a spherical secondary wavelets, and the sum of these secondary wavelets determines the form of the preceding wave at any subsequent time. So this is the funny part, right? Because the Huygens principle was used to tie light to light, to keep the line, to kind of force the soldiers to bend each other around a curve, like for diffraction. And so that's what Huygens came up with his theory for, was originally for diffraction, to explain why light bends in glass, for example. Why light hits a surface and it bends. And so the basic theory is that the light comes in and it hits the surface, and the light over here hits the surface later than the light over here. So these soldiers start going down and they force the other soldiers to turn. That's the original purpose of all this Huygens crap. So the idea is they're admitting that the source of the light is very, very far away, right? So they're conceding that they've unbent it, okay? It's not Huygensing in any specific way. But Huygens' principle was just basically, there's a bunch of little waves, and he had to make them an infinite number of them just so they would end up making another straight line here. So you don't have a straight line unless you make an infinite number. You can sort of understand that, right? You end up with these little gaps here. So if I made 10 wavelets, oh yeah, I'm going to end up with funny little nodes. That's not going to work. And that would make the next wave. The next wave would just be built on top of this in the Huygens. With Huygens in, the wave would be built that way. And that's how waves propagated. That's Huygens' theory. Now they've turned it into this kind of crap where we're going to pretend that the waves are coming in very flat and straight, and that somehow I'm going to Huygens, okay, so we'll just pretend that's an infinite number, and that each Huygens point source is going this way, and this way, and this way, and this way, and this way. And now I'm going to make the wave round. Well, why wasn't this wave round? Why wasn't this wave round? Why wasn't this wave round? Why isn't this wave round? Why isn't this? Why aren't all these getting roundiated? You know, why isn't this roundiating? You know, this new wave. Why isn't it Huygensing and now radiating in all kinds of weird ways? It doesn't make any sense. It's such a cheap maneuver to attempt to blame Huygens for the fact that they need to create a point source out of what they're considering a flat wave. So a flat wave is going into a slit, and they have to come up with some way to make it do this. All right. So it's and they can't use friction, obviously, right? So water, we know it's friction. Okay, the water sticks to these sides, loses velocity, slows the molecules down, and the rest of the molecules are still going fast. And because the molecules are all stuck to each other, they do this bending thing, this dragging thing. Okay, and the same is true for sound. Sound, the molecular structure near the surface is the air, is different than the air in the middle. And so the sound doesn't go here as well, and so these molecules slow down. And that's what bends the waves. But that's it. Okay, it's a medium thing. It's a thing that happens in atoms, in materials. It doesn't happen to light. So they have no reason to make this wave. And then on top of that, you know, they're saying, oh, let's blame Huygens. Let's say if I make a whole bunch of little waves here, that somehow I've made two waves. So their idea is that somehow, well, if I do this and I calculate all of these rays coming off all these infinite number, so I make the math insanely complicated because I have rays coming off all of these, that somehow that'll all average out to this. Okay? Now you have absolutely no reason to think it averages out to that, because it doesn't. And so what they do is they just bisect this, and then they just say this cancels out with this, and this cancels out with this, and this cancels out with this, and I'll just pretend there's only these two left. And that's all it is. It's pretending. There's no mechanical reasoning to this. There's no sense in it. It's just a nonsense. They use the word Huygens because it's weird and complicated and nobody can see it in their brain. And so everybody can be just fooled that somehow they created two waves where there aren't two waves. And the two waves are actually in the math coming from here, okay, and here. Right? That's where they're coming from, okay? So they have to be drawn here and here. Now you know that if some flat thing's coming in here, the waves aren't going to be made going through the material. Come on, that's nonsense. That would never happen in any other mechanical system. So we know that isn't the truth. So why do they keep claiming it is? This is explicitly what the math does. It compares a vector from here and it compares a vector from here and says, are they in phase? Or do the notches match? That's it. So don't let them, don't be fooled. Okay? They're just full of crap. This is just crap science. It's, like, again, I think if they did try to teach this crap in grammar school, the kids would rebel. They would know that you're just talking shit, right? You're talking a religion or something. You're not trying to tell me the truth. You're just making this shit up. It's shit. And you shouldn't be fooled by it. It's so obviously garbage. Alright, it's not a straightforward matter to calculate the displacement amplitude given by the sum of the secondary waves. So all they mean by that is that if you want to get explicit, really technical, and try to get your math to get exactly how bright each little spot will be and everything, you have to sort of understand that in the reality, when there is scatter on a surface, there's more scatter this way than this way or this way. So it gets weaker. Fewer and fewer bits will get scattered to all these. So if I was mashing cats, people like to use cats, or rabbits. Let's say rabbits. I'm throwing rabbits at a slit, and they're pieces of the rabbit are getting broken off, I'll have more pieces of rabbit going this way, then go this way, then go this way. So it gets less and less as you turn. So obviously if I made a Huygens thing where I made a ton of these, you'd have to calculate the fact that some of these rays are diminishing. They're not of equal intensity. So if I compare 2 point sources, if this angle is sharper than this angle, it means that there's more pieces coming from this one than comes from this one. So I have to figure that I'm not really throwing as many legs over here as I threw heads. So if this one's breaking heads off and this one's breaking legs off, I'll end up with more legs than I have heads, and I really won't be able to make rabbits. You know, I'll have some rabbits that are just a lot of legs and no head, and you know, they're not really rabbits, so they won't be photons. Yeah, so that gets complicated. But when you have an infinite number of waves, yeah, that you can't do that actually. So they admit right here, Veras can be solved in many cases. An analytic solution is not available. Yes, clearly you can't analyze infinite number of wavelets. A little concession by them. Okay. All right, so it says here, Fraunhofer diffraction equation is a simplified version of Kirchhoff's diffraction formula. So it's just all the same thing. It's just pretending that point sources that are scatter sources are somehow wave centers when there's no theory that makes them wave centers. There's no theory that makes it make any sense. All right. So it is garbage. All right, so let's see, where's, you know, for example, let's see, employed, if the viewing distance is greater than 100 millimeters, they usually say something like the plane, the viewing plane. Okay, so again, this is the far field, so it is when stuff is further away. But again, and the distance from the source is just to create the plane waves. Obviously, you don't need that as much with laser beams and such, but it really isn't about the waves coming in flat. Okay, it really is about the photons coming in coherent, that is in phase and in straight lines. Obviously you don't want the rays coming into the experiment going in all kinds of directions, because then that would be the cause of extra scatter. All right. The aperture, focal plane, parallel, yeah, well that's lenses, you really don't want to mess with that. All right. So in each of these examples, the aperture is illuminated by monochromatic plane wave at normal incidence. So they just, the whole idea that they have somehow demonstrated that light has anything to do with being a wave, when we know, you know, that there's a huge amount of physics that kind of demonstrates that photons are independent little corpuscles of momentum, and that they don't travel in any collection, okay, by any will of their own. Anyway, so W is the width of the slit, so it's right there, they've already given it away. The distance, the W right here, is the distance between the 2 point sources. That's giving you the angle differences, and so it's just about the differences. It's really just saying the 2 surfaces are this far apart and the 2 surfaces are point sources. And so it makes no sense to call this a wave theory when it's clearly just about the surfaces and it's just about scatter. All right, so so here it says the fringes extend to infinity in the y direction. Now I think for them the y direction is this way. They're not calculating the fringes going up and down, so that wouldn't make much sense for them to say that. Since the slit and the illumination also extend to infinity. So let's understand that there is no evidence that anything extends to infinity in any real way with any light source. So the fact is if you understand that it's rays, it's not waves. Right now, if you make everything waves, you could say, okay, well, this is a wave, and this is a wave, and this is a wave, and it goes to infinity, right? It never stops being a wave. It never stops being a continuous line. But if you understand it by ray theory, you understand that, oh, wait a minute, infinity is a long way away. And the truth is that infinity is going to be out of luck, okay? Because there's going to be so few photons getting to infinity. you know, in any one place. If I said here I am at infinity, I'm really far away. The fact is, I'll never get hit by any light from something infinitely far away from me, because the light is actually in rays. It's actually in rays, and the rays are all going in directions. And if I happen to be here, okay, the fact is it could take a trillion years, a zillion years. It could take an infinite number of years for me to be lucky enough to have a ray actually hit me at that distance, because there could be an infinite amount of distance between a photon and another photon. And therefore, I don't get hit by a photon at this location. This location, even if I run infinity for infinity amount of time, that one never gets hit. Because the distance, as you increase the infinity, okay, the infinity gets bigger and bigger. And there's no reason to think that every ray has to hit every point, because it doesn't. It's not a continuous line. It's a bunch of rays. And some rays will hit something, and some rays will never hit something. And that's just the way it is. So again, this is just really bad physics. So again, he says the infinite thing only because they're projecting it on a flat plane. Obviously, it is not an infinite pattern. The bars will not be infinite. Okay, what they will be doing is getting bigger and bigger and bigger. They'll stretch. And so you can sort of understand that at the final, so when I go this degrees, this degrees, this degrees. So when I go 99, right? I mean, when I go 89 degrees, all right? You know, at 89 degrees, almost 99, I'll be in one block. I'll be either light or dark, and I'll be in the infinity in there. That last block will be infinitely long if you want to think about it being projected on a flat plane. This is the only block that's infinitely long. The rest of these blocks are quite finite. This is the one that's infinite. Just one of them. And it'll either be on or off. But there won't be any fringe pattern that goes infinitely. There's not an infinite number of blocks. There's only one here, and then there's one here, and there's one here, and there's one here, and there's one here. And they travel through space. And the blocks just get bigger as you make the arc bigger, but it's the same blocks. If there's 5 blocks here, there's 5 blocks here, and there's 5 blocks here, and there's 5 blocks here. That doesn't go infinitely in any direction. So that's just silly nonsense. In the Wikipedia page, edited by physicists, no doubt, and they don't even know their own physics. Even to use this infinity word so casually just demonstrates they don't take their physics seriously. They really just don't care, okay, to talk about reality. They're talking about a fantasy world. They have no evidence that the universe is infinitely anything. Or you certainly have no evidence there's an infinite number of something in finite spaces. That's just nonsense. Made up garbage. Alright. Okay, so then they call this semi-qualitative, right? When it's supposed to be, I mean quantitative. Quantitative is supposed to be, we'll give you the right answer. And then they say it's semi the right answer. Explicit, complete, analytical. Quantitative is supposed to be analytical. It's supposed to give you the actual answer. Qualitative is supposed to be, here's the general theory. Even using these deceptive words is just so deceptive. Okay, this has nothing to do with quantity or quality. So they use these words to describe what is woo and double woo. They're little fake words to hide that they're just telling you a fable. So this is the semi-real fable. Yeah, so this fable has talking fish, okay, but it doesn't have flying giraffes. Okay, anyway, we can find the angle at which the minimum is obtained in the diffracted light. So they keep saying diffracted. So somehow it's bulged. The light is somehow going in all directions now. By the magical what? Oh, that's right, by the scatter on the surfaces. The only reason why the light's changing direction is because the light that goes near the surface is being scattered. And that's the only reason the light's changing direction. The only light that changes direction is the light that travels near the surfaces. You can understand that. Consider the light diffracted angle, so there's no point in me going over it. I just point out that this W, the whole thing is just, they're doing it right there. W is the distance between the 2 point sources. They divide it into the wavelength to find out the percentage of the line, okay, that will have a block in it. The number you get from that decision will tell you exactly how many light and dark changes you have in one 90-degree piece of the pie. It'll tell you exactly how many there are. And that's the end of the whole thing. It's over already. It's just how many wavelengths are the 2 point sources separated by. And whatever that number is, you just put it on the longer arc. You just multiply it times 1/2 pi, and you've got your answer. 1/2 pi is how much longer this arc line is than the radius. Okay. Single slit diffraction, electric fields, Huygens principle again. Just absolute nonsense. This drawing is nonsense, but we know what the distance always is, and the distance is always the distance between the surfaces. Always. Always, 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 always. It's never any other distance. They just measure how far apart the surfaces are. So it's just more nonsense. Let's read a little bit of this. We can develop an expression for the far field of a continuous ray of point sources of uniform amplitude and of the same phase. So they're just saying that look at all this complex math we have to do because we made a bunch of little fake waves, and now we're pretending that it didn't make a new flat wave. So that's all they're doing. They're saying that all of a sudden Huygens kicks in. And again, Huygens' principle was that it's continuous. Huygens' principle was to describe why waves propagate, why they jump from one place to another. So Huygens is about taking a wave and putting all these little humps on it to create the next wave. Huygens' principle didn't take flat waves and turn them into this. Okay, so what they're doing is they're saying, we're going to stop Huygensing. So we're going to stop doing that, and this will be the last Huygens. And at the last Huygens, now we'll start spreading the light. And so now we'll create an arc of all these things. We'll turn this flat wave into this. Now it doesn't do that mathematically. And clearly what the next step is they cut this in half and then turn it into 2 waves. And there's just no way to do that. That doesn't work. All right, this butt cheek theory is absolutely made up fabiology. Huygens wouldn't say, my theory predicts that. That's not what Huygens would say. My theory predicts that you put a plane wave in, you get 2 waves out. Huygens would never say that. I'm fairly certain he never said that. So anyway, this is all just crap. Okay, you have to be... this is just calculating, the density of the fur on a unicorn. I mean, it just has nothing to do with reality. All right, and so we did the rectangle thing. It's not too interesting. This shows the truth. You can see quite obviously there's more bands. Okay, the shorter the distance, the more bands you get. The wider the distance, the wider the distance, the more bands you get. The smaller the distance, the bigger the bands get, and the fewer you have. Okay, in the circular aperture, again, it's the same exact thing, just divided into the wavelength. Okay, there's just nothing here, nothing at all complicated. Blah, 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 blah. The output for the laser, you have intensity, maintains profile. So this is also not of great interest. So here's the double slit. As I pointed out, we know this isn't the real double slit pattern, that it starts up again and turns off again and starts up again, turns off again. That their notion that this light is 97% brighter than the bar next to it is nonsense. We know that doesn't happen. That the light doesn't degrade at any of that fast rate and all that kind of crap. As you can see, many, many, many bars. So they just made up all that stuff. Well, I probably should read it. In the double slit experiment, the 2 slits are illuminated by a single light beam. So they call it a beam of light, and they should call it a waverizer. A flashlight should be called like a waverizer or something. Okay, if the width of the slits is small enough, less than the wavelength of light. So why would you make slits that small? There's absolutely no reason. And so in most cases, the width of the slits will be a lot more than the wavelength of a light, because the wavelength of the light is so small you'd never even be able to see the pattern at a distance. There'd be so few photons capable of getting through. And so more nonsense. If you have the slits that small, you'll never get this bar pattern. Well, anyway, the slits diffract the light into a cylindrical waves. So they just said it, right? The slits turn them into cylindrical waves. Through what mechanism? Again, you know why water turns into cylindrical waves. There's no explanation for why light would do it. These two cylindrical wave fronts. So they just said it. These two cylindrical wave fronts are superimposed. So again, they're saying the double slit. This is double slit. He just said double slit, right? They just said it. So AB Science says this is correct math. This is the correct theory. Okay, the two waves. So he's still advocating that you can get the right answer by doing this and by doing this. So by having this distance and this distance, that's all I have to put into the math, is this distance and this distance, the center of the two waves, and I'll get this pattern. I'll get a pattern, okay, that has an envelope in it. This is the pattern I'll get. I'll get this empty spot, I'll get this empty spot, and these little notches will be the right size with these dimensions. That won't work. It's absolute crap. It can't work. The actual fact is that you have to use this distance to predict this envelope. And you have to use this big distance, this large distance, to predict the size of these nodes. You will not get the correct answer using this as the center and this as the center. The center of the wave has to be at this point and has to be at this point to get these things the right size. So this is just absolute crap. This Wikipedia page is absolute crap. Two-wave theory doesn't work. You have to have four waves. You have to have 4-point sources, or you will not predict the real double slit pattern. This web page, this Wikipedia page, is a pile of crap. Okay. If the width is small enough, okay, we already did that. These two cylindrical wave fronts are superimposed, so they travel through space and interfere with each other. The two waves. Nonsense. Okay, there's two waves in the single slit. Do you get how stupid this is? The single slit creates two waves. The double slit creates two waves. You see how stupid it is. Okay, and the amplitude and therefore the intensity at any point in the combined wavefronts depends on both the magnitude and the phase of the two wavefronts. Well, duh. But obviously the point is when you have these 4-point sources, you will have the idea that the one scattering from the furthest point and the one scattering from this point, this one obviously at this point will be more intense than this one. So there'll be a little bit of complication, but it's where the bars will be is as explicit as I explained it. The two outside surfaces dictate how small the little bands are, and the two inside surfaces tell you how the envelope pattern. All right. Depends on both the magnitude, blah, 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 blah. Okay, these fringes are often known as Young's fringes. So again, it's just so silly to call them Young's fringes when we know that Young didn't realize there was two patterns to the equation. Young's analysis was superficial. It is nowhere near complete. It doesn't work. Two waves will not answer the double slit conundrum. All right, it's just a nonsense. And look, the same thing. Take the distance between the point sources, divide it into the wavelength, and it'll tell you how many wavelengths are in the distance. Okay, and it'll tell you exactly where to put them on the arc. And that's it. It's so frickin' simple. I mean, it's crazy how simple it is, and yet they're answering the question completely wrong. You can't get the right answer with two waves. You can't do it. It's impossible. All right. The fringes in the picture were obtained using a yellow light from a sodium lamp, blah, 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 slit separated by 0.25 millimeters. I used to know how to convert that into how many wavelengths it would be. Okay, so a quarter 0.25 millimeters would be, that's a lot of wavelengths. You can see how many bars there are here, right? So 0.25 millimeters is like 1,000 wavelengths. So they have 1,000 bars. So if you could see the whole pattern, if you could go this way and see the whole thing, there was enough photons at the really obscure angles, okay, there'd be 1,000 bars. So if I put it on a curved screen, no matter how far away I put the curved screen, you would see 1,000 bars. So if I put it far away, the bars are big. I put it close, the bars are little, but there'll always be 1,000 bars. All right. The fringes in the picture were obtained using, okay, so, they're even conceding 1/4 of a millimeter, which is a very wide slit, and they described it as a very small slit. That's a very wide slit. Okay, and projected directly into an image plane, so here we go, of a digital camera. So we know that the image plane has to be curved if you're not going to see it distorted. If I look at this huge image, right, an image that's going way over here, so I have a movie projector and it's able to project on a really wide screen, the light goes way out here to the sides. You know that if you looked at a flat screen, the pixels would start stretching out. I mean, everybody'd start getting insanely fat. Okay, that's what's going to happen. Everything gets stretched to pieces. So you have to look at it on a curved screen to see it for what it is. All right. So this is done, right? I mean, this is just nonsense. They describe it as a tiny distance. It's a 0.5 millimeter. It's huge in terms of the number of wavelengths. It's more than 1,000. All right, anyway, double slit interference fringes can be obtained by cutting 2 slits of a piece of card. So even this is so stupid, right? To be talking about cutting a piece of paper because it creates a very uneven edge and blah, blah, blah. I mean, obviously, to get the right pattern, you have to do the experiment kind of carefully. So that's just bullshit. And observing the diffracted light at a distance of 1 meter. If the slit separation is see, they just keep giving you examples, and they're, as if their math works and it's right and it's sensible, when again, it can't be right and it can't get the right answer with 2 waves. All right, so again, semi-quantitative. So this again is saying semi-accurate. It's just nonsense. Is the difference in distance. So this is just telling you the obvious, that it's just 2 vectors. It's just 2 lines. And you're just seeing how much they're in phase, how much they're out of phase. If they're in phase, you get a photon. Out of phase, no photon. And so here they requalify the difference here. This path difference is equal to 1/2 a wavelength, 1.5 wavelengths, etc. Then the 2 waves cancel, and the summed intensity is 0. The effect is known as interference. So they call it diffraction, yet it's they concede it's interference. And again, just to acknowledge, I mean, the simple answer is that photons are in fact broken. Okay, they're rabbits when they go in. They're broken by this process. The little pieces of rabbit are thrown all over the place. And at some locations, you put the rabbit back together in the right order. Head, feet, tail. And in some places, you got tail, head, feet. And that rabbit ain't going to work, so you won't see that rabbit because he doesn't get to hop because he's broken. He stayed broken. So where you put the photons back in phase, you'll see them. Where you didn't put the photons back in phase, where the contributions aren't in phase and you're not reconnecting the rabbit pieces, you won't see a rabbit. It's that simple. All right, and the diffraction by a grating, it's just, they don't even cover it, and that's the really good equation. The diffraction by a grating, this is the equation that takes in the 4 point sources. See, but they don't point that out anywhere in this text, that you're using all of the surfaces. So you're counting all of the surfaces as contributions. So you don't just have one distance in the equation. You have the distance from every one of the surfaces. And that's the equation that actually works. Obviously. Because it has the number of sources in it. So it's just here, but it's just, it just has all the sources in it. You have to calculate the distance from the 2 furthest, the 2 closest, blah, 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 and then you'll get the right answer. All right, I don't think there's anything else here, but so they had the infinite part in here. The two waves will not give you the right answer. It's, you know, there's just so much garbage in this frickin' article. And again, it doesn't even do this. It doesn't even emphasize this, which is the equation that actually works. The concept that actually works, which is acknowledging that there's more surfaces here than just two. It's not a two wave equation, it's a four source equation. All right, I've been over it and over it, and I mean, if you people can't follow along yet, but just understand there's no way that AB Science can defend this page. It's nonsense, it's garbage, it's just full of crap, and there's no way he could draw any analysis that shows how two waves creates the two patterns, because two waves can't do it. Two sources can't create that pattern. Fact. Fact. I think that's enough. Yeah, we'll just keep it to this bullshit. This bullshit diffraction nonsense when it's an interference pattern. Clearly an interference pattern. And again, they don't show you any drawings of the waves interfering. None of those drawings are here because they can't be tied to math that works. They can't draw their math because it doesn't work.